In this video, I'm going to explain you how to show that the intersection of two subspace is again a subspace. So I'm taking here two subspace. Here I took A and B be two subspace of V over the field F. We have to show that A intersection B is a subspace. Okay. So how to prove this? We'll take two elements in A intersection B. Okay. I'm taking two elements in A intersection B. So this implies that both the element x and y will belongs to A and x and y will belongs to B. Okay, and I'm taking two scalars, alpha 1 and alpha 2 belongs to the field. Okay, alpha 1 and alpha 2 I'm taking from the field. Therefore, alpha 1x plus alpha 2y, this will belongs to A, since A is a subspace. Okay, is a subspace of V. Since A is a subspace of V, so this will belong to this. And alpha 1 x, okay, alpha 1 x plus alpha 2 y will also belongs to B. Okay, belongs to B because x and y belongs to B, and I'm taking, so the linear combination also will belongs to B since B is a subspace of A. Is a subspace of V. Okay, so we got this belongs to A, so as the reason is A is a subspace of V, and here also this belongs to B since B is a subspace of V. Okay, now these are same elements. The same element belongs to A as well as the same element belongs to B. So this means this element will belongs to A intersection B. So we have therefore alpha 1x plus alpha 2y will belongs to A intersection B. So we have shown that the linear combination belongs to A intersection B. Therefore, A intersection B is a subspace. Okay, it's a subspace of V over F. We get that this is a subspace of V over F. Now we are going to do the next theorem. So here we have, suppose A and B are two subspace of the vector space over the field F. Then we have to show that A plus B is also a subspace of V. Okay, so I'll take two elements from A plus B. Okay, I'm taking two elements from A plus B. So I take V1. So the elements of A plus B is of the form, okay, the elements of A plus B is of the form as A1 plus B1, where A1 belongs to A and B1 belongs to B. And V2 I'm taking as A2 plus B2, where A2 belongs to A and B2 belongs to B. Okay, so we have this. Now I'll take two scalars, alpha 1 and alpha 2 belongs to the field. Now let me take the linear combination. So alpha 1 V1 plus alpha 2 V2. I have to show this linear combination belongs to A plus B. Okay, so here we have what? I have alpha 1 A1 plus B1, and here we have alpha 2 alpha 2 A2 plus B2. Okay, so this will be alpha 1 A1 plus alpha 1 B1 plus alpha 2 A2 plus alpha 2 B2. But since these are all elements of a vector space and V plus is an abelian group, so we can commute the elements. So we can interchange these two positions. Okay, so we have here alpha 1 A1 plus alpha 2 A2 plus alpha 1 B1 plus alpha 2 B2. Okay, now A1 belongs to A and A2 also belongs to A, so the linear combination will belongs to A since A is a subspace of V. So this part, okay, this part belongs to A, and this part also belongs to B since B is a subspace of A. So this one will belongs to B, and this one will belongs to A. So this belongs to A means it will be some element as A does, which is in A, plus an element this belongs to B means this will be some element of b dash belongs to b. Now this element, this a dash belongs to a and b dash belongs to b, means this whole thing will belongs to a plus b. Okay, so we have shown that the linear combination belongs to a plus b. Therefore, a plus b is a subspace of V over F. Okay, so we have proved this. A plus B is a subspace of V over F. Now let us do this. Suppose we have this question. W is given by this. We have to prove that this is a subspace of R3. So here we are taking here. So this is your question. So this is your W1. I'll take two elements from W. So W1 equal to, okay, it will be of this type. So x1, 2x1 and 3x1. Okay, where x1 belongs to real number. So this I'm taking in W, and W2 also I'll take as x1 dash, 2x1 dash, 3x1 dash, or we can take x2 also. We can take here x2, 2x2, 3x2. Okay, so this belongs to W, where the one reason where x1 is from the real number, x1 is a real number, as well as x2 is also a real number. Okay, I'll take two scalars. I'm taking two scalars, alpha 1 and alpha 2 belongs to the field. Okay, now I have to show the linear combination alpha 1 w1 plus alpha 2 w2. This I have to show it is in w. Okay, I have to show this is in w. So this is equal to alpha 1 x1, 2x1, 3x1 plus alpha 2 x2, 2x2, 3x2. Okay, so this implies what? We get here alpha 1 x1 plus 2 comma 2 alpha 1 x1, 3 alpha 1 x1 plus alpha 2 x2, 2 alpha 2 x2, 3 alpha 2 x2. Okay, we get this, and from here if we add coordinate wise, okay, so we get alpha 1 x1 plus alpha 2 x2 comma 2 alpha 1 x1 plus 2 alpha 2 x2. Then we get 3 alpha 1 x1 plus 3 alpha 2 x2. So here we get what? We are getting here alpha 1 x1 plus alpha 2 x2. Take 2 common, so we get alpha 1 x1 plus alpha 2 x2 comma 3 alpha 1 x1 plus alpha 2 x2. Okay, so if we check here, I'll show you here. So this part, if you look, alpha 1 belongs to the field, okay, and x1 also belongs to the field. So this implies alpha 1 into x1 will belongs to the field. So product of two elements of the field is again inside a field. So this one will belongs to the field. In the same way, alpha 2 belongs to the field and x2 also belongs to the field. So the linear product, okay, alpha 2 into x2, this also will belongs to the field. Here the field is real number. Okay, so we are taking here R. Alpha 1 also belongs to R. Alpha 2 also belongs to R. So this product also will belongs to R. Okay, so here also this will belongs to R. Okay, so we got that here alpha 1 x1 belongs to R. Here alpha 2 x2 belongs to R. So both are belonging to R, means the summation of this, okay, summation of this also will belongs to real number. So this one is belonging to real number. So I think I can take this to be equal to some x dash. Okay, I can take this one equal to some x dash, where this x dash belongs to real number. Okay, so I'm taking here this as x dash. Okay, so we get 2x dash, and here we get 3x dash, where x dash belongs to real number. Okay, Now, if we look in this form, if we look the elements of W, okay, you look the elements of W and what we got here. When we look the elements of W, what we have? X, 2x, 3x, okay? And here, x belongs to real numbers. Here also we got x dots, 2x dots, 3x dots, where x dots belongs to real number. So it is of this form, okay? So this is nothing but an element of W. So this belongs to W. Since we have shown that the linear combination belongs to W, therefore W is a subspace, okay, is a subspace of R3. Thank you.